Okay, as I said before, sedimentary rocks are my favorite types of rocks, and that's because they tell us so much about the environment that they formed in. Okay? So we use sedimentary rocks to infer Earth history. A lot of what we know about how Earth developed and the climate of Earth in the past, the plate tectonics of Earth in the past, a lot of that is from sedimentary rocks. Right, so because sedimentary rocks are formed from processes that move sediment around, because water, moving water has such an important role in creating sedimentary rocks actually preserve those mechanisms, preserve evidence of those mechanisms. So for example, ripples that form from flowing water can be preserved in the rock, right? We can actually see those ripples in a rock. And the shape of those ripples can tell us about how fast the water was flowing and what direction the water was flowing. If the water was flowing only in one direction, like a river, or in two directions, like waves, right? Those ripples in the rock can preserve the type of environment, tell us about the environment the rock was created in. It can also preserve fossils, right? Evidence of past animals. So anytime you see a fossil of a dinosaur footprint, those fossils are going to be in sedimentary rock, right? What used to be just sediment that could move around and was squishy like mud, and then after the dinosaur stepped in it, that mud was solidified, lithified into a solid rock, preserving evidence of that creature in the past. Now, the layers of sedimentary rock also tell us a lot of information. So some new vocabulary here. Strata just means a single rock layer, and a bedding plane is the surface in between those two different strata, different rock layers. Right? So the way we can use strata and bedding planes, one of my favorite ways is through cross-bedding. So anytime sediment is moving, either because of wind or water, and that sediment creates little ripples or little dunes, it preserves cross-bedding within it. So if you were to slice down into a ripple, you could see these bedding planes that are at an angle. And those bedding planes tell us what direction the sediment was moving in, right? What was the wind direction? What was the water flow direction? All right, mud cracks are another really useful tool to interpret in sedimentary rocks. Anytime we see mud cracks in a sedimentary rock, we know that that rock was created in a really dry, arid place, right? A place that used to be wet, and then it dried out, cracking that mud. Right, so sedimentary rocks are fantastic because if we see a sedimentary rock, we look at the material that it's made out of, the size of the sediment, the rounding of the sediment, the sorting of the sediment, the fossils that are contained within it, the structures like cross-bedding that are contained within it. We can figure out where that rock was formed. And because we know that Earth is constantly changing, right? If we find a rock that was formed in a, so for example, let's say in Brunswick, we dig down and we find a conglomerate. Well, conglomerates aren't normally made in places like Brunswick, right? They're normally made in places like the bottom of a mountain, like closer to the Appalachian Mountains. So that would tell us that Brunswick a long, long time ago used to look more like a mountain, right? So seeing rocks that are at a location, but that the rock indicates a different environment than what we see today, tells us that that environment has changed over time, which I think is just fascinating.